server project. The next presentation is going to be a 3D high density accelerator system presented by Terry Powell from Nostra. Sorry.
Okay, welcome everybody. My name is Terry. I'm the server hardware lead in Wiwynn. So today I'm going to talk about the very interesting product concept from Wiwynn. This is the 3U high performance accelerator systems. We have the nickname of that. It's Dr. No. Probably you know the movie of AI. This is one of the characters in that movie. Okay, so what's Dr. No? Dr. No, simply put it this way, Dr. No is one of the external PCIe box. It's a PCIe carriers to carry all the PCIe like the graphic cards or the accelerator cards. We don't make the accelerator cards, but we build the carriers for that. Okay, so the features of that is that the resource pool is going to support up to 4 hosts, so it allows to connect to the 4 hosts through external cables. And on this accelerator pool, it can support up to 16 by 16 PCIe devices, or you can use like a 32 by 8 PCIe devices. Okay, so this is a module design. So it's a 4 PCIe drawers. You can see the 4 PCIe. The PCIe drawers you can pull out and maintain very easy. And we have the out-chassis management, and the power supply is a 2+1 redundant. I'm going to focus on 4 topics, 4 key points of the Dr. No. So the module design, the management, and the flexibilities, and also serviceabilities. Before jumping into the first module design, here is the block diagram. You can see that this is the Dr. No. Actually, this is the external host to connect to. So this is the block diagrams. You can see there's a 4 baseboard drawers, so each are identical. And we have the 1 I/O modules to connect to. So you have internal connections to 2 baseboards. Okay, I'll talk about more details later. So the module design. As you know, the module, each drawer is actually the PCIe interface. So you can just pull out the drawers and plug in the other one, or whatever it's a PCIe devices you can put in. So the current design is they have the 97 lanes PCI switch on the baseboard. So that means you can have like a 4 by 16 PCIe or 8 by 8 PCIe slots on the baseboard. And also there's 2 input or outputs on the front. So one for the host, the other one for the daisy chain or cascading to the second baseboard. And we do have the 40 additional power supply, power connectors for the high power accelerator computing devices. Okay. And also like maybe you're not going to use the accelerators. Probably you can plug in the fusion IOs like flash to become a very powerful or high performance storage. Okay. So on the management, we have the on-chassis management. We use the XP chip, and definitely they'll offer you the temperature sensoring, voltages, power consuming, and also you can control the fan speed, LEDs, and also all the configurations on the PCI switches. So interfaces. The interface here means the connections to the host or to let the users to configure the EMC or the PCI switch. So you can have the connect from the host to I2C to configure the BMC, or to the network to configure the BMC, to read the BMC, and then configure the PCIEs. So we think the applications of this Dr. node, we're going to support, be part of these fields. So we are collecting data, we are collecting the applications from everybody these 2 days. So we hope this can help on this. I believe there will be more. So if you do have some inputs to us, maybe we can exchange the information to make it the kernel better. Okay. So for the applications, this is the flexibility for the applications. We believe if you connect to 4 hosts through the external cables, that means each of the drawers, the PCI drawers, is direct attached to the host. This is a typical case for using. Okay, so that means each one you can have 4 PCIe GPU cards to attach to the host and have the acceleration compute powers. If you need more computing powers, acceleration powers, you can just unplug 2 hosts. Take up 2 hosts, because they already have the I/O modules and already have the internal connections. So that means each host can direct connect to 8 PCIe cards, the big cards. And I also have other crazy ideas. You want to support 1 host with 16 PCIes, you can just add another like retimers or some external PCI connectors on 1 host. So offer like a 2x16 outputs. So you can also connect to the I modules to make it 1 host to 16. If you don't want to do that, you can just add external cables, because also data chains, everything data chain. So it's 1 host to 16. Very big. But I'm wondering, maybe this data is very, very big, so you probably know I'm going to use that. But this is showing the capabilities and the flexibilities connected to the Dr. nodes, to the viewer. Maybe already have the service in your rack. Okay. So the original design on the Dr. node is we designed to fit into the 19-inch rack. So this is the whole everything in 19-inch racks. This is the 3U high and the 800mm step. So everything is the front access. The power supply is also front access. And the fan modules, this rear, you can service from the rear. So everything, the design is based on the 19 inches. However, we are thinking about why not just share the same design and put into the 21 inches CP rack. It's an easy way to do that. So you just, because OCP rack, everything is from the front. So the bus bar, you change the whole rear side, change the bus bar, and the fan modules, so keep the same, but it's just because these are individual fan modules, you just plug into it. So you change these rear panels. It will be easy to fit in the fan modules, and the reroute the external cable to the front to have the fix here. Then this is 21 inches chassis that allows you to fit into the 21 inches OCP rack. Okay, this is the flexibilities, and then also the serviceabilities. So I put one page of the summaries to talk about the factor notes. So modular design, you can set modular design baseboard support up to 16 by 16 PCI device, PCI graphic cards. Management abilities, you can have the on-chip DMC, also easy to monitor or configure the system. And also the flexibility is a configurable resource input. And also it's a 19 inches rack, and then also extendable to 21 inches rack. Definitely, sophisticated is a very toolless design for the whole compute cards and power supplies and fan modules. Okay, I think that's it. Is there any questions?
Short presentation, so we've got plenty of time for questions.
Does anyone have any questions on the design?
Or if you want to see more the systems, you can come to our Wiwynn booth at B3.
Okay, anyone have any questions? Thank you, Terry.
Thank you.